Good morning. This is Dr. Sailaja, Associate Professor of Mathematics, MLR Institute of Technology, Hyderabad. In the Mathematics course, Probability, Statistics and Complex Analysis, today we are going to study about the topics types of random variables, discrete and continuous random variables, and properties of random variables, mean, variance of discrete and continuous random variables. So before defining the random variable, what is a scientific experiment? What is the difference between scientific experiment and a random experiment? In scientific experiment, when a person is performed a scientific experiment, they know what is the output we may get. That means there is a certainty in the output of the scientific experiment. In random experiment, we know the outcomes of the random experiment, but when the experiment is performed, which output we may get, that is there is no certainty. That means in scientific experiment, there is a certainty in the outcome, whereas in random experiment, there is a uncertainty in the output. For example, if we take tossing a coin, the outcomes are either head or tail. If the random experiment tossing a coin is performed, sometimes we may get head, sometimes we may get tail. That means there is no certainty in the output. So that's why tossing a coin, throwing a die and drawing a pack of cards, these are all random experiments. So in this course, we take all the random experiments and we study about the probability and different types of random variables and their properties, and based on that we solve some problems. So what is the sample space? Sample space is a set of all possible outcomes of a random experiment. So here tossing two coins. Here the random experiment is tossing two coins. Then sample space is set of all possible outcomes. So here two coins means on one coin head appear, on the second coin tail may appear. Sometimes on both the coins head appear. Sometimes no head appear on either of the coins. That is, on the two coins, tail may appear. So these are all possible outcomes when tossing two coins, the random experiment is happened. So similarly, throwing a die. When a die is thrown, then the set of all possible outcomes are either 1 or 2 or 3 or 4 or 5 or 6. Either of these outcomes we may get. But there is no certainty which outcome we may get. So that's why these are all random experiments. So basically, sample space is set of all possible outcomes in a random experiment. That is denoted by capital guess. Now the random variable is a mathematical function which maps from sample space S to the real number R. Suppose the same experiment we have taken tossing two coins. The set of all possible outcomes that is denoted by capital S, and these are all possible outcomes. And here the random variable X is defined as number of heads appear. Number of heads appear. So in the first outcome, there are two heads. In the second outcome, one head occur. In the third outcome, one head occur. In the fourth outcome, only tail occurred. No head appear. So that's why 0. So based on this random variable X, number of heads appear, based on this random variable, we take X values, that is 0, 1, 2. So here sample space S is set of all possible outcomes HH, HT, TH and TT. So this is mapped to real numbers, subset of real numbers. So here the real numbers are 0, 1, 2. So in this outcome 2 heads. So this is mapped to this. And in this outcome 1 head. So this is the mapping. TH. Here also 1 head appeared. TT. No head appeared. So that's why this is 0. So random variable is a function. The domain is the set of all possible outcomes and the codomain or range is subset of real numbers. Now these random variables are categorized into two ways, that is discrete random variable and continuous random variable. So what is the difference between discrete and continuous random variable? Discrete random variable capital X is a discrete random variable only if X takes integers or finite number of values. X strictly takes integers means X is either positive integer or negative integers also it may take. And in continuous random variable, X takes real numbers. X belongs to real numbers. So that means here X may be intervals. X belongs to, suppose for example we are taking X belongs to the interval 0, 1. There are so many real numbers between 0 and 1, that is 0.001, 0.005, 0.009, 0.12, 0.15 and so on. So these are all infinitely many real numbers between 0 and 1. So that's why this X is continuous random variable. So in discrete random variable, X takes only integers, and in continuous random variable, X takes real numbers. So that's why always we take the intervals X belongs to A, B in continuous random variable. In discrete random variable, we can take the examples as number of students in particular section, in particular class. So there is a finite value, some 60 students or 50 students or 40 students, like this. Similarly, number of stars in the sky. This is also integer. And in continuous random variable, we can take the examples as heights of students, 5'2", 5'10", 5'8", like that. Similarly, speed of a vehicle, 40 kilometers per hour, 41.5 kilometers per hour. So these are all real numbers. So that's why height of students, speed of a vehicle, all these are examples of a continuous random variable. So here we discussed discrete random variable. In discrete random variable, X takes integers, and in continuous random variable, X takes real values. Now we define the discrete probability distribution or probability mass function. Suppose capital X is discrete random variable. So what is the probability mass function of this discrete random variable? So here two conditions are there. Total probability must be equal to 1 and each probability, that each probability of x value must be greater than or equal to 0. If these two conditions are satisfied, then we say that capital X is a probability mass function. Suppose, for example, we take tossing 2 coins. So X takes the values. Earlier we have discussed X takes the values 0, 1, 2. And the probability of each X value, P of X, this is denoted by probability of no head appeared. That is denoted by probability of X equal to 0. So what is probability of X equal to 0? And we know that when 2 coins are tossed, H, H, HT, TH, TT. These are the possible outcomes. So in this, probability of X equal to 0 means no heads occurred in any in the outcome. So here only one outcome is there. In this outcome, no head occurred. So that's why what is the probability of X equal to 0? Out of 4 outcomes, there is only one outcome in which no head occurred. So probability of X equal to 0 is 1 by 4. Similarly, probability of one head occurred. One head occurred. So this is denoted by probability of X equal to 1. So probability of X equal to 1 means one head occurred. Here we have 2 outcomes in which only one head occurred. This one and this one. So here the probability of HT, probability of HT is 1 by 4. Out of 4 outcomes, probability of HT is 1 by 4 and probability of TH is also 1 by 4. So probability of X is equal to 1. We got the total probability 1 by 4 plus 1 by 4. That is 1 by 2. Similarly, probability of X is equal to 2. X equal to 2 means 2 heads occurred. So the such type of outcome is only one. That is HH. So in this outcome 2 heads occurred. So what is the probability of H comma H? Out of 4 outcomes, only one outcome in which 2 outcomes occurred. So that's why 1 by 4 is the probability. So probability of X is equal to 2 is 1 by 4. So here we take probability of X is 0, X equal to 0 is 1 by 4, X equal to 1 is 1 by 2, X is equal to 2 is 1 by 4. This is the probability distribution. Now this probability distribution is a probability mass function if these two conditions are satisfied. That means for each X value, probability is there. So each probability, that is P1, P2, P3, all these are greater than 0. This is the second condition. Each probability is greater than or equal to 0. So this is second condition and total probability is equal to 1. Whenever the random experiment happened or occurred or performed, then the total probability of each X value must be equal to 1. So 1 by 4 plus 1 by 2 plus 1 by 4, which is equal to 1. If these two conditions are satisfied, then this is probability mass function. So in general, we define the probability mass function as X values, P of X values, X1, X2, X3, Xn. The corresponding probabilities of these X values are P1, P2, P3 and so on, Pn. This is probability distribution. Now the probability mass function we can define as each probability must be greater than 0. That is, Pi is greater than or equal to 0 for every I equal to 1 to n. Similarly, total probability is equal to 1. That is, summation Pi equal to 1. I equal to 1, 2, 3 and so on, n. That is P1 plus P2 plus P3 plus Pn equal to 1. So this is, in general, we can define the probability mass function of a discrete random variable. So here we can take, already we discussed about this example. So here only single coin is tossed. So either head or tail is the outcomes. Then what is probability of, here x, the random variable is defined as x is number of heads. So either head or tail may occur. So here if tail occurred means no head appeared. So that's why x is equal to 0. If head occurred means x is equal to 1. So x is equal to 0, x is equal to 1. So x takes strictly the values are integers. So that's why this is a discrete random variable. So the probability of x is equal to 0 is, that is 1 by 2. Since two outcomes, one either head or tail. Out of two outcomes, x is equal to 0 means a tail appeared. In this outcome, no head appeared. So what is the probability of a tail is 1 by 2. And probability of x is equal to 1, that is only one outcome out of two outcomes. So that probability also 1 by 2. So P1 and P2. So each probability is greater than 0 and the sum of the probabilities, that is P1 plus P2 equal to 1. So this is probability mass function of a discrete random variable. Now how to find the mean of a discrete random variable? So here we take the probability mass function x1, x2, xn, p1, p2, pn, corresponding probabilities. So here this is probability mass function of a discrete random variable. Then the mean of the discrete random variable is denoted by E of x or mu, expectation of x or mu. Here x is a discrete random variable and x takes the values x1, x2, x3, xn, finite number of values, and moreover all these values are integers. So mean definition is summation I is equal to 1 to n xi into p of xi, or simply we can write this as summation x into p of x, that is x1 p1 plus x2 p2 plus so on plus xn pn. This is mean of discrete random variable which is denoted by mu or expectation of x. In general, we can write expectation of x power n. Summation xi into pi. Expectation of x square is summation xi square into pi. Expectation of x cube is summation xi cube into pi. In general, expectation of x power n equal to summation xi power n into pi. So like that we can define expectation of x power n as summation x power n into p of x. Similarly, we can define the variance of a discrete random variable. It is denoted by sigma square and it is given by e of x square, that is this e of x square minus e of x whole square, where e of x is mu. So this can be written as e of x square minus mu square. Since e of x is mu, mean, mean or e of x or mu. So that's why we can write it as e of x square minus mu square. From this we can find the standard deviation, that is denoted by sigma equal to under root sigma. After finding the variance, we can find the square root of the variance, that is a standard deviation, and it is denoted by sigma. Now, in continuous random variable, how to define the probability mass function or probability density function of capital X. Here capital X is continuous random variable. In discrete random variable, we can define the probability for each x value, since x is a integer and finite number of values. But in continuous random variable, x takes real values, and there are between any two real numbers or any two integers, there are infinitely many real numbers. So that's why we can't define the probability for each x value. So we take the probability in the intervals, in different intervals. That means what is the probability? Here the probability is denoted by in continuous random variable f of x. So what is f of x in different intervals? A comma b. Similarly c comma d. These are all intervals, and there are infinitely many real numbers between a and b, between c and d. So for all the x values between a and b, we define the same probability f of x. Similarly, we define different probability in different intervals c comma d. So that is f of x is greater than or equal to 0, and the second condition is integral minus infinity to infinity f of x dx is equal to 1. In discrete random variable, summation pi equal to 1. Total probability is equal to 1. Whereas in continuous random variable, we take this condition as integral minus infinity to infinity f of x dx equal to 1. Suppose here this is x-axis, minus infinity to infinity, and this is 0. So minus infinity to infinity, the total interval, minus infinity to infinity, we take the probability f of x, then we integrate. If this integral value is equal to 1, then this is the condition. Second condition, total probability is equal to 1. The first condition is the probability in each interval must be greater than or equal to 0. In discrete also, the same condition, that is pi greater than or equal to 0 for every I. In discrete. In continuous, the same condition we define like this: f of x is greater than or equal to 0 in each interval. So if these two conditions are satisfied, then the given capital X is probability density function. And we can find the probabilities in different intervals like a to b. In the interval, this is a, this is b. To find the probability, what is the probability between a and b? Then we take the interval as a to b, f of x dx. To find the probability a to b, we can denote either less than or equal to or less than. All the notations are same to find the probability between a and b. Integral a to b, f of x dx. How to find the mean and variance of a continuous random variable? In discrete random variable, the mean is mu equal to summation xi into pi. Here also the same formula, but instead of summation, we take the integration mu equal to integral minus infinity to infinity x into f of x dx. So in discrete random variable, we take the summation. In continuous random variable, we take the integration. Since we can't define the probability for each x value in continuous random variable, it is possible in discrete random variables. So that's why we take the summation and we add all the probabilities for each x value. In general, we take the expectation of x power n as integral minus infinity to infinity x power n into f of x dx. Suppose expectation of x square is integral minus infinity to infinity x square into f of x dx. X cube is integral minus infinity to infinity x power x cube into f of x dx. So we write in general expectation of x power n as integral minus infinity to infinity x power n into f of x dx. Similarly, variance also x minus mu whole square or expectation of x square minus e of x whole square. This e of x is mu only. So it can be denoted by mu also. So e of x square, that is, this is the formula, minus mu square. This is the formula for mu square. So e of x square minus e of x whole square is the formula to find the variance of continuous random variable. So as we discussed earlier, a standard deviation is the square root of the variance and it is denoted by sigma. Now the properties of expectation are expectation of ax plus b, where a and b are some constants. A and b are constants. Then a into expectation of x plus b. And expectation of a constant is a constant. Variance of ax is a square into variance of x. So these are all properties of expectation and variance of a random variable. Thank you.